Welcome to Comprehensive Code YouTube channel. Today we'll be solving Leetcode 140, word break second. Let's read the question first and understand it. We are given a string S and a dictionary of string word dictionary. Add spaces in S in the string to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Let's take this as an example, okay? So if we see here, it's let's start from here. It's C in our dictionary, no. It's CA in our dictionary, no. It's CAT in our dictionary, yes, it is. That's why this can be one word, okay? And it's okay. Now we are left with this word, okay? Now we start from here. It's S in our dictionary, no. It's SA in our dictionary, no. Is SAN in our dictionary, no. Is a SAND in our dictionary, yes, it is here. And then we take this one, okay, and we can add that. So far we have cat, sand, okay, and then we start from here, do the same thing. Is D in the dictionary? No. Is O in the dictionary? No. Is G in the dictionary? No. Oh yes, DOG is in the dictionary, okay. So once we find this, we have cat, sand, and dog. So cat, sand, and dog. This is a valid sentence. Also, let's start another way. So if we go here and see, like, is C in our dictionary? No. Is A in our dictionary? No. Okay. And then is T in our CAT in our dictionary? Yes, but we already used that. It's CATS in our dictionary. Yes, that is. So one can be CATS, and then is A in our dictionary? No. Is AN in our dictionary? No. Is AND in our dictionary? Yes, it is. So cats, and we found cats and so far. And is D in our dictionary? No. Is O in our dictionary? No. Is DOG in our dictionary? DOG. Yes, DOG is in our dictionary. So we add cats and dog. So basically cats and dog is here. So you'll have cats and dog and cat and dog. All right. So let's think how we can solve this problem. One way we can think of is, for every word in this string, like every character in this string, check, like, is C in our dictionary? No. You include both of these. Is CA in our dictionary? No. Is CAT in our dictionary? Yes, we add that in the result. We can do this in a brute force way like this. However, we can also do in reverse way. For example, like, we start from the words. For every words, we'll see if our string starts with cat. It is if it starts with cat, we'll take that and then we pass the remaining words in the recursive function. So if we do that, we do it in recursive way and recursive way in backtracking fashion. So let's see in the code. Like, I think it's a little bit unclear now, but if we go in the code, we can it will be more clear. I'll explain it line by line. With that, let's start coding, and we can talk about the space and time complexity later after the coding part is done. All right. So the first thing is, like I said, we can define our depth first search function, and then what it does is basically it takes a substring, okay. So the substring will basically be the string at the beginning, and we'll chop off the remaining part as we go, okay. Now let's see what we can do. If the substring is empty, if we don't have substring, we just return empty string, okay, like this, okay. And then now what we said is, for word in So another thing we just do is, like, let's say the local result, and we have to store the local result for each of these sentences. Okay, now let's iterate for all of the word in word dict, right? What we do is, if the substring dot starts with the word then we'll find the subwords. Okay, the subwords will be the DFS of the substring. What will be the substring? We already took up to substring up to the word, right? Okay, yeah, we already took this word, and now we have to pass the substring after this word. For example, if we took this cat, then we have to pass sans dog in next iteration. I hope that makes sense. Now what we'll do is we can return the subwords. Okay, all right, and then we just return, we call this DFS function, and we just pass the string, and that should be, oh, we have to also, what we have to do is, okay, we have that, and for each of this word in the subwords, we have to add that in the local result dot append, and we add this word. Okay, and then we can add space if we have that word, else we don't need to add anything, and then plus the word itself, and at last we return the local result, not the subwords. Okay, I think that should be it. Let's run this code. Okay, it's passing, but we don't have any memoization done yet, because the result, for example, like if dog was already calculated earlier, this will calculate again, and which will take long time. If we don't do the memoization, it might fail. It still passed, but let's do the memoization and see if we can improve the performance. Okay, so see, let's add a memoization, like it's called DP. Okay, and if the substring in DP, we just return the substring. Okay, and then at last, like, we just add the DP of that substring as the local result, so that, like, this, for this substring, the result is already memoized, and if we find that substring already, the solution for that substring already calculated, we'll just return that instead of going through this loop. I hope that makes sense. With that, let's run this code again, and okay, it failed. Let's see what failed. It's in dog. Okay, we just return not substring, but we return the DP of that substring. Sorry, right? Okay, let's run that code. Okay, as you can see, the tests are passed, and let's run this code. Yeah, as you can see that the performance is improved a little bit. So that's about it, and let's talk about the space and time complexity real quick. So as we are going through, iterating through all of the words in dictionary and doing this DFS search, and the time complexity for this would be order of 2 to the power n, as we are doing those recursive call for all of the words in the word dict, and the space complexity is also order of 2 to the power n. Yeah, and that's all for this, and it's pretty simple. So if you like this solution and if you find this helpful, please hit like and subscribe, and it will help me grow a lot in this channel. And thank you for watching this, and hopefully we'll meet soon.